Again, we want to show convergence or divergence. The sum n equals 1 to infinity, negative 2n divided by 3n plus 1 to the 3n power. And right away, your brain, after a little bit of practice, is going to tell you, ooh, I should maybe use the ratio test in this. But wait, I have in parentheses a formula involving n, and then an exponent involving n. Let's not use the ratio test. Let's use the root test. Because when you have a formula involving n to some kind of n power or multiple of an n power, the root test often works nicely. So let's go with the root test. That's the thought process. So write down generically the nth root of the absolute value of an. You need, remember what the root test says. Let me go back to it. The root test says you need to determine what the limit of that thing does as n goes to infinity. And then you can apply the root test to it. So that's why we write it down first. So we write that down, nth root of absolute value of an. And here, do the absolute values matter? They do. So let's write that down. The nth root of the absolute value of the quantity negative 2n divided by 3n plus 1, that whole thing to the 3n power, and then close the absolute value. All that is going on underneath the radical. So make your radical big enough so I know that you know that that's one big radical and everything is happening underneath that radical. Okay, here's the thing. Exponentiation, taking exponents. It's multiple applications of multiplication, right? So x cubed means x times x times x. The absolute value splits up over multiplication. So it's okay to say something like this. If you have the absolute value of, let's say, I'll use different, I'm trying to be generic here, so I'll use different bases here. Let's say you have b to the n, and you're taking the absolute value of it. Then it is true that that's the same as the absolute value of b to the n power. Whoops. Because you're just multiplying b times itself n times, and we know that for multiplication, the absolute value splits up, essentially. So you can use that property all day long to help you out here. Why would we want to use that property? So in this case, I'm saying I can pull, okay, everybody look up. I can pull this exponent outside the absolute values. That's essentially what I'm trying to get across to you. So that we have the absolute value of negative 2n over 3n plus 1, and that whole thing brought to the 3n. So why did I want to do that? Well, I want to use the nth root and the 3n power to kind of get rid of the root. And the best way algebraically to remember how this works is to write the nth root as a rational exponent, a fraction. So what the nth root is the same as what power? Yeah, so you could rewrite this thing as, if you wanted to drop the absolute value, you could just delete the negative at this point. Because again, absolute value splits up over multiplication. And if you split that up and had a factor of absolute value of negative 2, that would just be 2. So you could do that and then use parentheses instead of absolute values. And then, okay, brackets. That nth root can be written as the 1 over n power. Stare at that. Make sure you agree with that from what you remember from algebra. So all I did was get rid of the absolute values by deleting the negative, and then rewrite the nth root as 1 over a power of 1 over n. Okay, now when you have an exponent on the inside like this and an exponent on the outside, what's the appropriate law of exponents to use? You keep the base and you multiply the exponents. Remember that? Exponent on the inside, exponent on the outside, you multiply. Don't add, you multiply. That's the law. Okay, so that gives us 2n over 3n plus 1 to the what power? Just the third is all that's left when the smoke settles. The third power. Okay. Let me broaden the view a little bit. Now, what do you think that guy converges to? Say it again, I didn't hear you. 2/3 to the third. 8 over 27, yeah, exactly. This one, I think, if asked, you should be able to show some explanation. And in that case, it might be easier on you to switch to LIM notation. So if you're forced to explain why this thing converges to 8 over 27, here's a good explanation. You could say in the next step, I was going to say note that, you don't need that. I'll just use the symbolism. Limit n goes to infinity of 2n over 3n plus 1 cubed is the same as, really what you can do is bring the limit to the inside and cube the whole thing. It's the same as the limit as n goes to infinity of 2n over 3n plus 1, the whole thing cubed. And then you can use that property we used in the last one. Oh, inside the parentheses, you have the same powers, the same degree in both the numerator and the denominator. So inside the parentheses, what does that limit converge to? What do? You take it's a rational function, degree of the numerator equals the degree of the denominator. So that limit as n goes to infinity of that rational function is just the ratio of those lead coefficients, right? Inside the parentheses, which is 2/3, but outside the parentheses you have cubed, so 8/27. Well, let's not circle that, because really that's just a means to an end. So you get 8/27s. How does that compare with 1? It's less than 1, so what's your conclusion? So the series converges absolutely, or is absolutely convergent, same thing. Converges absolutely by the root test. There you go. Okay, so just to summarize, if you're using either the ratio test or the root test, you're first going to write down the generic sequence formula you're interested in. For the root test, it's the nth root of the absolute value of an. For the ratio test, it's the absolute value of an plus 1 divided by an. So you write that down, or in this case, you write down what you need for the root test, and then you fill it in with the specific values involved from the an that you're given. And then you simplify, and you then see what the limit of that simplified version of this formula looks like, and what it does as n goes to infinity. And then you compare it with 1. You compare that limit with 1 and make your conclusion. You hope it doesn't equal 1, otherwise you have to try a different test for convergence.